Hello and welcome to this presentation on setting up position mode in RoboG4 products. The motor we will use in this presentation is a BLDC type, and we will demonstrate how to control it in position mode with a RoboG4 BLDC drive using any of the supported motor sensors. Position mode uses the combination of closed loop and feed-forward control to drive the motor to the desired position. Robotech drives employ a cascaded control mode where position, speed, and torque loops work collaboratively to drive the motor to the desired set point. Thus, it's essential to first configure and evaluate open loop, torque, and speed modes before diving into position mode configuration. For more information about configuring the other loops, please refer to the respective videos and quick startup guides. Let's now move on to the controller configuration. To start, connect the USB cable to the drive and open the RoboRun Plus utility. Load the configurations from the drive. These should have been based on your previous open loop, torque mode, and speed mode tuning. Essential parameters such as the number of pole pairs, the FOC gains, and speed gains should have already been set, and the motor sensor setup process should have been completed to calibrate the motor sensors. The closed loop sensors should have been set during the speed mode configuration. The other option corresponds to quadrature encoders and SSI sensors, while internal relates to Hall, sine cosine, or resolver sensors. If multiple motor sensors are available, it's preferable to use a sensor with the highest resolution as feedback. If encoders or SSI sensors are used, configure them to act as feedback and select the appropriate channel. The sensor's resolution should have been set earlier during the open loop configuration. Set the desired motion profile. Each time the motor is commanded, it will reach the target position by following a trajectory with defined acceleration, constant speed, and deceleration. The constant speed is set using the position mode velocity parameter. Next, set the desired acceleration and deceleration for the motor. Choose values that the motor can realistically achieve under load, taking into consideration both the controller's and the motor's current limitations. Higher acceleration and deceleration values will require more current during operation. Set the operating mode to count position mode. Robotech drives support various position modes, with count position being the most common. In this mode, the motor is commanded to move to a position represented by the number of sensor counts. The motor follows the configured motion profile to reach the target position. Temporarily disable the closed loop error detection. This error detection will be triggered if the motor response is slower than expected, which could indicate a motor failure or an overload condition. At this stage, where the motor is not yet properly tuned, this feature should not be taken into account. Next, set the closed loop position PID gains. Position mode tuning is primarily done using the proportional gain. The tuning process should be carried out while the motor is operating under its nominal load, as the system characteristics can vary with different loads. Begin by assigning a small value to the proportional gain, such as 0.1. Since the position error is measured in counts, the power supplied to the motor will depend on the sensor's resolution. The motor can be commanded using the P command. The first argument of the command corresponds to the channel, and the second command to the set position measured in counts. Monitor the motor trajectory and actual position through track and feedback variables. The loop error parameter can be used to assess the motor's response. The smaller the maximum value of the error, the more closely the desired trajectory will be followed. To tune the motor, gradually increase the proportional gain until the motor feedback closely follows the position command. If the final position is not precisely reached, a small amount of integral gain can be applied. However, be aware that a high integral value may introduce an overshoot or even a constant loop error. Position PID control alone may not be sufficient to precisely tune the motors for accurate trajectory following. This is due to the fact that closed-loop control inherently requires some loop error to generate a response. To further enhance motor performance, position feed-forward control can be used. This method supplies an additional amount of power during motion, proportional to the motor's velocity demand. Since this extra power is based on the commanded velocity rather than the loop error, it provides a boost that helps achieve more precise and responsive motion. To enable position feed-forward control, set a non-zero value for the velocity acceleration parameter. Start with a value of 1 and gradually increase it until the desired results are achieved. Increasing the feed-forward gain beyond a certain point will cause the feedback to lead the track command, resulting in a loop error in the opposite direction. Retain the gain value that produces the minimum absolute value of the error. The motor can be considered tuned when the track command and feedback values almost coincide. One reason this may not happen, aside from tuning, could be the power limitations of the system. The required movement might demand current that exceeds the motor or drive capabilities. In this case, either the motion profile may need to be adjusted, or you should consider upgrading the motor or drive. This concludes our presentation. By following the steps outlined, you should have successfully configured and tuned the motor in count position mode. Feel free to subscribe to Robotech's channel for more informative videos, and don't hesitate to contact our technical support if you have any further questions. Thank you for watching.